For the last 10 years, we believed a simple lie, that if we just built bigger neural networks and fed them more of the internet, they would eventually learn how to think. But in early 2026, the technology hit a physical and economic wall. Trillion-parameter models are consuming entire power grids, yet they still fail at basic tasks requiring multi-step planning. The era of the prompt is ending, replaced by a strange new architecture that does something AI has never done before. It stops, doubts itself, and thinks twice. To understand why AI systems break down, we have to look at how they actually generate answers. When you type a prompt into a standard large language model, it uses a feed-forward architecture. This means it generates the next word, and then the next, in a single, continuous forward pass. It cannot stop. It cannot look back. It has no backspace key. In April 2026, researchers released a new benchmark called LongCoT, consisting of 2,500 highly complex, multi-step problems designed to test how models navigate long-term planning. The results were telling. Because standard models must commit to their output immediately, a tiny logical error made its step 2 cascades, compounding silently over 30 or 40 steps. By the end of the chain, the model is confidently outputting complete nonsense. It does not realize it made a mistake because its architecture physically prevents it from checking its own work. Think of a traditional language model as an old-fashioned printing press. Once the lead type is cast and stamped onto the page, it is permanent. If the operator makes an error on the first sentence, they cannot fix it without melting down the entire page and starting over. But recursive agent frameworks act more like a steam engine centrifugal governor. Instead of executing a task in one heavy, irreversible push, the system uses a closed-loop feedback mechanism. The output of the model is fed back into itself as a new input. It reads its own thoughts, compares them against its environment, and adjusts its direction in real time. The AI is no longer just typing. It is reading, editing, and self-regulating. In May 2026, a groundbreaking preprint paper titled S-AI-Recursive proposed a radical alternative to massive feed-forward models. Instead of running 1 trillion parameters for every simple question, researchers designed a bio-inspired, temporally sparse architecture that uses simulated hormones to control its reasoning process. The system relies on 2 primary digital signals, confusionin, which represents uncertainty, and clarifying, which represents logical convergence. When the model is given a complex problem, it runs a series of fast, energy-frugal loops. If the system detects logical contradictions in its draft, its simulated confusionin levels spike. This spike triggers the model to run another recursive reasoning cycle, digging deeper and searching for errors. Only when its internal clarifying signal peaks does the model stop iterating and present its final, self-corrected answer to the user. This is a massive shift from trying to build an all-knowing oracle to building a system that simply knows when it is confused. This is not just academic theory. In mid-2026, developers deployed an end-to-end agent harness known as AI VIS Co-Scientists. Standard AI code generators can write a snippet of code, but they cannot run it, test it, or see if the final software actually works. The co-scientist framework changes this entirely. When given a high-level goal, such as visualizing a massive climate dataset, the recursive agent does not just output code. It spins up an isolated sandbox environment, writes the software, executes it, and analyzes the visual output. If the code crashes or the visualization looks wrong, the agent reads the error logs, inspects the visual layout, and recursively refines the code until the program runs perfectly. The human does not write prompts. The human simply sets the target goal, and the recursive loop handles the execution and debugging. The driving force behind this architectural shift is not just capability, it is cold, hard economics. Training a trillion-parameter model costs tens of millions of dollars and requires massive data centers. But running a small, highly optimized 7 billion parameter model is incredibly cheap. By shifting the computational burden from training time to inference time, recursive frameworks allow these smaller models to match the performance of industry giants. Instead of paying for one massive, expensive guess, developers pay for 100 cheap, lightning-fast self-corrections. It is far more cost-effective to let a lightweight model think for 3 minutes than to query an industrial-scale model once. This structural change fundamentally rewrites our relationship with technology. For years, we viewed AI through the lens of traditional tool use. We were the active creators, typing prompts, and the machine was the passive responder. But as recursive agent frameworks take hold, those roles are reversing. The AI is no longer a passive autocomplete box waiting for your next keystroke. It is an active agent that runs autonomously for hours or days, navigating complex decision graphs, correcting its own mistakes, and presenting completed projects. The human is no longer the writer. We are becoming the editors, supervisors, and architects of high-level goals. Of course, this new frontier comes with its own set of dangers. When you give an AI system the power to run its own execution loops, you introduce the risk of infinite computation cycles, where a confused agent could spin endlessly, draining computing budgets in minutes. There are also deep security concerns when autonomous agents are given the authority to write and execute code on live networks without human intervention. The transition to recursive AI is not a magic solution to every limitation of machine learning, but it is a necessary evolution. We are moving away from the brute force scaling of raw data towards systems designed with patience, introspection, and self-awareness. The future of intelligence is not a larger dictionary. It is a mind that knows how to think before it speaks.